Myself, Dr. K. Viswanath Allamraju, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study how to draw a cam profile of a roller follower when it is moving with a simple harmonic motion during outstroke and return strokes. So, before going to draw, we have to know the problem. The problem was given here. It is a cam profile with a minimum radius of 25 mm rotating clockwise at a uniform speed is to be designed to give a roller follower at the end of the valve rod motion described below. So, to raise, it is the uniform speed of what? Of rotating cam. To raise the valve through 50 mm during 120 degrees of rotation of the cam, and to keep the valve fully raised through the next 30 degrees, to keep the valve, that means keep the valve is the word, that is a dwelling. Let me read first, then I'll explain it. To lower the valve during next 60 degree, and to keep the valve closed during rest of revolution of 150 degree. So the diameter of the roller is 20 mm, the roller follower, so 20 millimeters, and the diameter of camshaft is 25 mm, that is the minimum diameter of the cam. Draw the profile of the cam when the line of the stroke of the valve rod passes through the axis of the camshaft. And another one is, it is offset case, that there is the line of stroke is offset 15 millimeters from the axis of the camshaft. One more thing here, it is the displacement of the valve while being raised and lowered is to take place with displacement of the valve, that is the follower, is to be raised, is to take place with simple harmonic motion. Determine the maximum acceleration of the valve rod when the camshaft rotates at 100 revolutions per minute. Draw the displacement, the velocity and the acceleration diagrams for one complete revolution of the cam. So here is a very important problem. Is the highly practical oriented data was given here. Very important. What is the rotation of the follower? Here the mentioned, it is uniform speed and it is a simple harmonic motion. There is simple harmonic motion and it is uniform speed. Here it is, the valve is the follower and we have to consider the motion of the follower, that is a valve here. That motion is a simple harmonic motion during outstroke and return stroke. And there is, what is the meaning of here uniform speed? Here it is uniform speed of what? Cam. It is this term related to the cam. But we have to consider the terms related to the follower. That's why here it is which terms you have to consider. That is the motion. That is simple harmonic motion. Next, what is the type of follower? The follower is a roller follower because based on the data, the diameter of the roller is 20 millimeters. Diameter of the roller is 20 millimeters and the diameter of the camshaft is 25 millimeters. Okay. First of all, we have to use to raise. This is the term. This is the minimum radius of the cam is 25 millimeters. To raise the valve through 50 millimeters during 120 degrees of rotation of the cam. That is the meaning. This is the data related to outstroke. Theta outstroke equal to 120 degree. What is the stroke of the follower? The stroke or lift of the follower is 50 millimeter. That is from sentence 1. This is the data. To keep the valve fully raised through next to 30 degrees, that is the dwelling stage. Theta outstroke dwell, that is 30 degrees. To lower the valve during next 60 degree, if the lowering coming, that is the return stroke. Theta return is 60 degree. To keep the valve remains closed for the during the rest of the revolution, that is theta return dwell, that equal to 150 degree. So if you combine it, what is the 120, 150 total? The outstroke rotation plus outstroke dwell plus return stroke and return stroke dwell total, it becomes 360 degree. So with the 360 degree, that means for one complete surface or rotation. Now we have to consider, we have to draw the displacement diagram first. Whenever if we want to draw the cam profile, first we have to draw the displacement diagram. How to draw the displacement diagram? Let's take scale again. Scale. This is x-axis and y-axis. On x-axis, we'll take the rotation of the cam. Rotation of the cam is in terms of angles. That angles is converted into the linear scale by using the scale conversion assumption. And the y-axis, on the y-axis, we consider the stroke of the follower or lift of the follower. That is given here 50 millimeters. Now how to consider it? Theta outstroke, that is consider it. It is equal even number. So you can take it 15 degrees equal to 1 centimeter or 20 degrees equal to 1 centimeter. That will be better, or 30 degrees equal to 1 centimeter. That is okay. So consider it 30 degrees equal to 1 centimeter. Now when we take 30 degrees equal to 1 centimeter, you can divide such a way that, or 20 degrees equal to 1 centimeter it is also. So then what will happen? Yes, it becomes easy to convert into 6 equal divisions. So 20 degrees equal to 1 centimeters. Then what will happen? 1 centimeter, that is theta outward stroke, that is 120 degree. On x-axis it becomes 6 centimeters. Theta outward stroke d, OD, theta OD equal to 30 degrees. That becomes 1.5 centimeter. Theta return 60 degrees, that is 60 degree converted into linear scale in terms of centimeters. That becomes 3 centimeters. Theta return d, that is 150 centimeters. So 150 by 2, that is 7.5 centimeters. So with this summation of all these outward stroke scale conversions, draw a line. That line is total, that is outstroke, that is theta outstroke. The length is how much? 6 centimeters, that is 120 degree. Theta outstroke dwell 30 degrees, that is 1.5 centimeter. Theta return stroke is how much? Return stroke is 60 degrees, that is 3 centimeters. Theta return stroke dwell remaining, that is 7 point. Return stroke dwell is how much? What is the angle? Return stroke dwell 150 degrees, that is 7.5 centimeters. Even though we are mentioning here in terms of angles, but we have to show present here degrees. But these degrees are in the form of the length, linear scale. That is 20 degrees equal to 1 centimeter we consider, that is 6 centimeters length, okay, and so on. Now, what is the lift of the follower? That comes on y-axis, axis y. After the lift, then you join, complete the portion. This is the lift of the follower. How much it is? The lift of the follower is given 50 millimeters. Here, the valve rises completely 50 millimeters. So mention here, that is 50 millimeters, because I mentioned here it is the dwell zone. Join the vertical lines by these partitions, okay. With these partitions, draw a vertical lines, okay. Now after that, what to do? Divide this outstroke angle length into equal divisions, even number. So 4 parts, 6 divisions, 8, 12. So I am considering every session, but it's optimum. There was 6 parts you consider it. That is, so each indicates 1 centimeter. So I'm using here freehand sketch, but you have to use a scale in order to draw straight lines. Pencil. Okay, every class I'm mentioning the instrument required are pencil, scale, eraser, compass, protractor and set squares. So similarly outstroke, it is a 60 degree, that means 3 centimeters. 3 centimeters, 6 parts. How many? That is called 0.5 centimeters each part. Divide into equal number of parts. Similarly, divide into equal number of parts. So join all the parts into equal parts. Okay. Then what will happen? Join the equal number of parts here. Okay. After joining this equal number of parts, now, so approximately I'm drawing here. Okay. Now after this, what to do? Make a center line. This is the simple harmonic motion displacement diagram we are drawing. So make it, draw a center line. After making the center line, with the help of the compass, take 25 millimeters radius, draw a circular arc. This is a circular arc. Divide this circular arc into equal number of divisions, that is even number, that is a 6. 0, 1, 2, 3, 4, 5, 6. Okay. And after that joining, divide this into again 6 equal angular divisions. That is 180 by 3, 180 by 6, 30 degrees. You mark it in terms of, it is up to you. You can change any letters. I am taking as 1, 2, 3, 4, 5, 6. So draw a horizontal line which intersects at 1 with 1. This is the point. Next 2 with 2. Next 3 with 3. 4 with 4. 5 with 5. Join all these points with a smooth curve. That curve indicates the SHM curve. If you join all these points, this is the SHM curve and dwell. Similarly, transfer these points onto the outstroke. So, and transfer these points on outstroke 5. I am marking here. Here it is 6. Here it is 0.6 dash or 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash and 0. So this 5 is intersecting with the 5. Draw a line with the 5 point. Similarly 4 is horizontally. It is the 4th. It is 3. 2 with the 2 dash is a 2 dash line, and it is 1 dash line. So by joining all this, again join a curve that gives the simple harmonic motion curve during out to stroke. Smooth curve comes. So this curve is known as the simple harmonic curve of a roller follower having simple harmonic motion. Yes, simple harmonic curve of a roller follower. The outstroke is 120 degrees and dwell during outstroke is 30 degrees and return stroke is 60 degrees. Dwell during return is 150 degrees with a lift or stroke of 50 millimeters. So you can mark these points into the intersecting points A, B, C, D, E, F, and it becomes G, H, I, J, K, L, M. Like that in different notations according to, because these are the vertical displacements required for us to draw the cam profile while drawing the while drawing the cam profile at temptation. In that we need these vertical displacements. Okay, now let us begin how to draw the how it looks like. uh, Really, this is the diagram. So the curve looks like that. This red color represents that is the SHM curve of a displacement. The same procedure you have to follow. Okay. So outstroke I converted value raised. This is nothing but a theta outstroke. It is a dwell theta outstroke during dwell. It is the lowered theta return, and it is dwell during return. That is the total scale. Now one more thing is that the lift is 50 millimeter that we consider as S, that is 0.05 meters. Outstroke is 120 degree, convert into radians, that is 2 times pi by 3. Okay, that is 2.1 radians. Next theta are 60 degree, that is pi by 3 radians, and n equal to 100 rpm. This is the rotation of the cam. After drawing this displacement diagram, we have to draw the cam profile. This displacement diagram helps the displacement of the follower for a particular rotation, angle of rotation of the cam. So if you see here, for every 20 degree, the rise of the cam is this much. Okay, it is for 40 degrees, this much 2 to C. 3 to D 60 degree, 4 to E 80 degrees, 5 to F 100 degrees, 6 to G 120 degree. For 120 degree, the total lift, the valve raised, how much it is raised is 50 millimeter. It is remains, valve remains raised, that means open. Here it is mentioning open, that means for 30 degrees of cam rotation. Then it starts closing. What is that? When it is valve is lowered, means that it starts closing. It is 60 degree for every 10 degrees of rotation of the cam. HUJ again 10, coming next to 10 degrees of rotation, coming closer. How much it is closed? We have to measure the distance, vertical distance. Next, like that, if you draw coming, it is completely closed, 50 millimeters. Again, it will be open. For it becomes a dwell for 150 degree of the cam rotation. It remains a dwell, remains closed. Okay. Here again, when valve is raised, that means valve open here, or depends upon opening or closing, and it remains same. Again lowering, again it remains same. So this is the curve of simple harmonic motion. Displacement diagram is the diagram of rotation of the cam versus the lift of the follower. Here what is it dependent, what is independent parameters? Rotation of the cam is independent and lift of the follower is the dependent. So this lift of the follower is dependent on the rotation of the cam. Now how to draw the cam profile? Okay. Now this is a roller follower. The roller follower, we are considering only first case, one case study. That is the case study one is that the axis of the roller follower is passing through the center of the cam. So what is the minimum radius? The minimum radius of the cam is 25 millimeter and the diameter of the roller is 20 millimeters. First case we are studying, the line of the stroke of the valve rod passes through the axis of the camshaft. That is the meaning here. We are following that case study in this class. Now here a cam with a minimum radius of how much? 25 millimeters. So 25 millimeters, that is the minimum radius, and it is 20 millimeters. So how to draw? Let us begin. Start. Draw a 25 millimeters radius of a base circle. You have to draw first. Now this is the radius of the cam, 25 millimeters radius, that is 50 millimeters diameter. Now what is the radius of the roller? The radius of the roller is, the diameter of the roller is 20, that means radius of the roller is 10 millimeters. So the 10 millimeters take a distance, that is the 10 millimeters distance, draw a roller. This is the roller. This is the roller. Okay. Now draw the center, from the center of the cam through the center of the roller. That circle is known as a prime circle. Okay, draw a circle. With the help of compass. This is the prime circle. This is base circle. Now divide the prime circle into outstroke angle with outstroke angles. Outstroke, dwell during outstroke and return stroke, and dwell during return stroke. Now what is that outstroke? That is 120 degrees. Draw a radial lines, that is approximately 120 degrees. This is the cam. Now position of the cam. This is the reference axis, 120 degrees. 120 plus 30, 150. Next, 150 plus 60, 210. Okay, it becomes 210. Remaining angle, this is 210 degrees. Remaining is, it will be 150 degrees. Divide this prime circle into even number of parts which were divided here, which already divided. The 6 equal parts in outstroke. In displacement diagram, we divided outstroke into 6 parts. So divide into 6 equal. That means each indicates 20 degrees. So divide this into equal number of divisions. So this is point A. This is 1. It is 2. It is 3, 4, 5 and 6. Next, remaining outstroke, return stroke also divide into equal. Then this is, here it is shown here 0 dash. Okay, 0 dash here. Okay, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 6 dash. So draw a radial lines passing through this. Similarly, now after drawing these lines, these are the, now what to do after that? Take a vertical displacement from the displacement diagram 1 to B. Now what is that 1? From 1 to B, mark this point 1 to B. This is a B. Next, 2 to C. Take a vertical distance from point 2 to C. 3 to D. This is a point 3 to D. 3 to D. Next, 4 to E. Take approximately, it becomes here. 4 to E. 5 to, this is a 4 to E. 5 to E. Mark here from 5 to E. 4 to E. 5 to F. This is the 5 to F. Next, 6 to G. There is a distance. The center 6 to, it is the G. Similarly, from O dash to H. This is the O dash and it is approximately H. And 1 dash to J. This is the point J to 1 dash. What is the distance 1 dash to J? Next, similarly 2 dash to K, 3 dash to L, 4 dash to M. Okay, one more I left here. That is the 5 dash radial line. This is the 5 dash radial line. You draw 5 dash radial line. Next, 5 dash to, what is the 5 dash to N? This is 5 dash to N. So this A, B, C, D, E, F, G, H, J, K, L, M, N all are centers of roller. So you draw a centers of roller, that means you have to draw a roller there. What is the roller diameter? Roller radius is, the roller diameter is 20 millimeters. So what is the diameter of the roller? The diameter of the roller is 20 millimeter. That means take 10 millimeters radius. Okay. Draw the roller here. It may be intersecting each other. It's okay. Draw a 10 millimeters radius and draw roller. With this, H is the center, J is the center, K, L, M, N, and it is 6. Now, this roller surface is touching with the base circle. So the surface is in touch with the surface of the cam. The surface of the roller is in touch with the surface of the roller. So we have to draw a smooth curve by touching the surfaces of all rollers which were drawn here through the centers of A, B, C, D, E, F, G, H, J, K, L, M, N. That curve indicates the follower. Now I am drawing the cam profile. Now this is the cam profile. When the follower is the roller follower and the axis of the roller follower is passing through the axis of the camshaft. So this is the way of this is the procedure of drawing the cam profile. So I have drawn the freehand by manually without using any instruments, but you have to use the instruments of such as compass and a straight that scale or a rule that is called a steel rule or whatever. But another thing is a pencil, eraser, set squares and protractor. So after following this procedure, your picture will be looks like that. This is the way. profile of the cam. So there is the base circle, the camshaft, the base circle. Okay, everything how it looks like that. You can see the manually I have drawn, but you can also you have to get this a shape of the cam, the which is red color here. That is the shape of the cam under the given conditions. The given conditions are during outstroke it is 120 degrees, and return stroke it is 30 degrees. Dwell is the 30 degrees and return stroke is 60 degrees, and dwell during the return is 150 degrees. So instead of outstroke and return stroke, they mentioned here it is valve raised, next valve lowered, like that. Okay, that is the way of drawing. So what is the first step again? For drawing the cam profile, first step, draw a base circle. Second step, draw the roller on the axis passing through the camshaft. If it is offset, then you have to draw the offset circle, and touching the tangent line you have to draw. Next, after drawing the cam roller and take the center of the roller and the center from the center of the base circle, draw a circle, that is a prime circle, and on the prime circle you have to divide the prime circle into given the outstroke, dwell and return stroke angles, and you have to subdivide the outstroke into even number of parts or same number of parts which we divided or which we divided in the displacement graph and outstroke linear scale. And same after dividing sub angles, we have to mark the vertical distances from the displacement diagram and mark the same onto the from pi circle surface to on the radial lines. Then those points are the center of the rollers, where you have to draw again rollers with a given dimension and draw a smooth curve by touching the surface of the all rollers. That curve gives the cam profile. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.